So today, we're going to pull back the curtain and decode the secret language of AI. It's called vector embeddings. Now, this is the core concept that lets a machine understand not just words, but the meaning behind them. Seriously, if you can get your head around this, you'll understand how modern AI actually thinks.
Let's just start with a fun little riddle. What do you get if you take king, subtract man, and then add woman? The answer is queen, but not just because it sort of feels right. The answer is queen because of a specific mathematical principle that shows us something absolutely incredible about how we can teach computers to reason. We're going to solve it together in just a bit.
Okay, so to solve that riddle with math, we first have to tackle a really fundamental challenge in artificial intelligence. How in the world do you get a computer, a machine that only speaks in numbers, to understand the meaning of a word?
Right, here's the core of the problem. Computers, at their heart, just get numbers. Ones and zeros, mathematical operations, that's their entire world. But us, we live in a world of concepts, of ideas, of really nuanced meanings. So how do you translate a rich, kind of messy idea like love or justice into cold, hard numbers that a computer can actually work with?
Well, the answer is a brilliant idea called vector embeddings. Now, the formal definition you see here, yeah, it sounds pretty dense, representing words as a big list of numbers in some high-dimensional space. It's a mouthful. Let's just ignore the jargon for a second, because there's a much easier way to picture this. I want you to imagine a giant, multidimensional map. Let's call it a map of meaning. On this map, every single concept you can think of, every word, every sentence, you could even do it with images, gets its own unique address, a specific set of coordinates, a single point on this map. Okay, so we've got this map. How is it organized? Is it just a bunch of random dots scattered everywhere? Absolutely not. The way the map is structured, well, that's where the real magic happens. This map is what we call an embedding space. And the most important thing you need to get is that the geometry here, it isn't random. The distances and the angles between all the concepts are designed on purpose to represent their real-world relationships. In other words, the map is the meaning. So the number one rule of this map is super simple. Proximity equals relatedness. The coordinate for dog is going to be right next to the coordinate for puppy. And both of those are in the same neighborhood as cat. But all of them are miles and miles away from concepts like skyscraper or rocket. So closeness on the map literally means closeness in meaning. But it gets even cooler. Once every concept has coordinates, you can actually start to do math on them. And this is where things go from just being clever to being truly mind-blowing. Remember our riddle from the beginning? Let's solve it on the map. You can see here, we start at the coordinate for king. Then we literally subtract the vector for man, so we move away from that concept, and we add the vector for woman. And where do we land? Bam! Right at the coordinate for queen. It's not magic, it's just math. And this isn't just some cute party trick. This has a formal name. It's called embedding arithmetic. The reason it works is because the relationships between concepts, things like gender, royalty, even verb tenses, are encoded as consistent directions and distances on the map. This lets an AI do reasoning by analogy using really simple vector math.
So how does the computer actually measure closeness? A lot of the time, it uses a metric called cosine similarity. Now, instead of just measuring the straight line distance between 2 points, it measures the angle between their vectors. Think of it this way. If two vectors have a really small angle between them, it means they're pointing in the same conceptual direction. That makes them closely related, no matter how popular or frequent those words are.
Now, you might be wondering, okay, who actually builds these incredible maps? It's not like someone is drawing them by hand. No, they're learned by AI models that go out and analyze massive, and I mean massive, amounts of text. And the techniques for doing this have gotten way more sophisticated over time. You know, the early methods were pretty simple. They basically just counted how often words appeared next to each other, almost like tossing all the words in a book into a big bag and ignoring the sentence structure. Then, later techniques got a bit smarter and started to find hidden themes. But today's models? Whoa, they're on another level entirely. They learn by analyzing how words are used in context across billions of sentences, letting them build these incredibly rich and nuanced maps of meaning. So why does all this abstract talk about maps and vectors and coordinates actually matter to you? Because this technology is already changing how you interact with information every single day, especially when it comes to search. I mean, just look at the difference here.
Old-school keyword search was literal, almost kind of dumb. You'd type running shoes, and it would just look for pages that had the exact words running and shoes. But semantic search, which is powered by these embeddings, is totally different. It understands your intent. You can search for something like, what are the best shoes for jogging on a trail? And it gets it. It knows that jogging is related to running, and that trail means you probably need good grip. It finds related concepts, not just exact words.
But, okay, there's a catch. Searching a map with billions of points is a huge computational challenge. Trying to check your question against every single point one by one would be impossibly slow. You need a much, much more efficient way to navigate the space to find the closest matches almost instantly. And that is where vector databases come in. You can think of them as the high-speed GPS for our map of meaning. They are built specifically to do one thing really, really well: store and query billions of these vector embeddings to find the nearest neighbors to your query in the blink of an eye. They are the absolute essential backbone for any big semantic application. And trust me, this is not science fiction. We are using this map everywhere, right now. It powers the semantic search in engines like Google. It's how a shopping site knows to recommend a product that's similar to one you just looked at. It's used to find hidden patterns in huge data sets. And it's a critical piece of advanced AI systems like Retrieval Augmented Generation, or RAG, which helps chatbots give much more accurate, fact-based answers. So think about it. We've taken the messy, chaotic world of human language and turned it into a structured, mathematical map. We've given AI a way to understand what our words actually mean. So the question this leaves us with is pretty profound. If we can map out language, what's next? What other complex parts of our world can AI learn to map, navigate, and maybe truly understand?